I think the other thing as well with Rivan is that we don't intend on keeping this all closed off. So maybe contrary to my point earlier around partnering with companies or licensing the technology, hopefully what this will show is this is a pathway in terms of just the thermodynamics of capturing carbon and producing hydrogen, and actually a useful synthetic fuel at the end that is on par or close to fossil derivatives. I think if we can show that we can do that, I think many others will follow suit.
Carbonsations, today's carbon industry leaders.
Are you passionate about climate action and staying on top of the latest trends in the world of carbon capture, removal, and markets? Then the Carbon Herald has you covered. Every week, we bring you the top news, breakthroughs, and insights from the world of carbon management, delivered straight to your inbox. No fluff, no jargon, just the essential info you need to stay informed. So whether you're a climate professional or just someone who cares, make sure you're subscribed. Visit carbonherald.com and sign up today for our weekly newsletter. Welcome to the Carbonsations podcast, where we speak to some of the leading figures in the emerging carbon industry. Joining us for today's episode is Harvey Hodd, CEO and founder of synthetic fuels manufacturer Rivan Industries. Harvey, thanks so much for being here. It's a pleasure to have you on this show. Now, before we get into all the fun things Rivan is doing, I'd love it if you could share with us a little bit about what you used to do before founding the company and what essentially led you into this industry to begin with.
Sure. Thank you very much for having me. My background's in software development. So I founded and built two software companies prior to Rivan, in a very, very different space. SaaS software is basically ultimately enabling people to sell products online in varying different aspects. And it really, the kind of relevancy here was just, it was the first kind of taste of building a company for me, raising capital, building a team, just generally the trials and tribulations of building a company. And I think off the back of my second company, I came out with far more resource than I thought. We exited to a fairly large American company, and it basically came to this idea that I really enjoy I just really enjoy the work, and I deal well with two things. I deal well with complexity, and I deal well with learning things rapidly. And as such, I wanted to go into something far more meaningful than kind of an abstracted software. And really, that's kind of where Rivan started. And I can run through everything of how we got to where we are today.
Yeah. So actually about that, why did you choose to focus on this particular space? And if you could perhaps share the early story, like who was involved, what problem were you trying to solve in the climate space, and that others weren't addressing?
Sure. I think right at the start, I was looking at how really significant infrastructure and large-scale infrastructure is seldom built anymore. I think that this was actually the first starting point. So huge projects that are capital intensive, that are long-term, that are complex, are just very, very hard to get off the ground. And I think that's why you don't get that many young founders building these types of companies, simply for those reasons. And I think they're the kind of projects, they're the kind of companies that actually need to get built within the climate space. Just to really move the needle on things, I think large-scale infrastructure is often required. You can only do so much from kind of my background in software. And actually, that's really where I started. And then from there, I started looking into various areas that you'd kind of loosely define as climate. So that was hydrogen, carbon capturing batteries, mining, solar was a core tenet to everything I did. And basically all of this research kept coming back to ultimately two things. Capturing carbon is a problem of our time, and looking into the mechanisms by which we're doing so via credits, and just the technologies that are currently being deployed, I kind of became, quite a little skeptical of that. And then number two, looking at how the learning rates of solar and batteries are so vast that pretty much everything in my mind that isn't flying or doesn't have flying in energy density requirement or a molecular requirement, e.g. chemicals, cement, things like that, are going to be electrified. So there's this kind of strange area where you get these very heavy industries that require a molecule. So even as good as batteries will become and the learning rate that it will take them to, and the energy density that will happen, there are just some industries that you can't you can't attach an electron in and just leave it to do its thing. Unlike say transport within EVs, for example. And then on the other side, looking at just the mechanisms to capture carbon, I think if carbon capturing is built on a credit-based system, which is a little tricky to drive a learning rate, to really drive down the price. And then you look at what pricing we actually need to get to in terms of some of the largest companies in the world, oil and gas and construction, that actually if you take 1% of their profits relative to their CO2 emissions, like actually what price we need to get to is in the very low dollars per ton. And I didn't think those two mechanisms aligned. And as such, we ultimately came to this fairly contrarian hypotheses within synthetic fuels, which, is kind of led to our strategy at the moment.
So on that note, if you could share more with, especially as like those of our audience who are not familiar with your work, could you share more what exactly your strategy and how your technology plays into that?
Sure. So I think really on carbon capturing, our belief is that ultimately, a credit-based system is pricing something that previously wasn't priced, e.g., the carbon emissions from a large emitter. And therefore, that emitter is always going to fight, ultimately, because they're paying for something that they previously weren't paying for. And that puts pressure on government. They have to act, ultimately, government, to do so. But it always means that there's this antagonism for a credit-based system. It's slightly fragile. And if you really want to drive down the cost of capturing carbon, which is ultimately what our aim should be, irrelevant of kind of what we're doing, you need to induce a learning rate, like any large-scale technology that is seen, a Ford Model T, a CD player, an iPhone. All of these things have learning rates which are really predicated on, you can distill it down into every doubling of production, what is the drop of pricing. And for that to happen, for a really vast learning rate, like solar has, for example, like batteries have, for example, there's a few core variables that are important. One being has to be almost a commodity-based good. It has to be quite simple. It's very useful to be simple because you manufacture so many of them. Like a solar panel is a good example. If I don't purchase a solar panel from a specific manufacturer, the price is so elastic that I would just immediately go to another manufacturer, and they would have to, the manufacturer I moved away from would have to drop their price to come and win my business, because the product is basically identical. That's really important. At the moment, we don't really have that. You have all these emerging technologies, and nothing is kind of the winning route as of yet. And then also some of the other things that we saw as tricky, or I saw as tricky right at the start of the company to really drive the cost of carbon capturing down, were things how like a policy might be in place for say 10 years, but some of the large scale carbon capturing deployments need financing for say 20. And that's really difficult for large scale institutional and debt funding to actually fund these projects. And that's where you get those, bridges where there's almost no capital available for certain deployments. And then ultimately it's just as such as a kind of a combination of those two, you just don't get enough scale to dramatically deploy large scale carbon capturing sites and plants. And as such, that learning rate is very slow. For example, I think actually if we look at the 50 gigatons or so of carbon capturing right now, that's doubled in maybe 4 or 5 years and has a learning rate of about 11%, I think. So for every doubling of production, about 11% drop in pricing. We've got to double that every few months if we really want to get down to the pricing. So I think, therefore, I was looking for a better mechanism to drive down that pricing, which I think is more rooted in very built markets, very understood distribution, very well kind of financed deployments, and all of that led partially to basically valorizing the CO2 into a synthetic fuel. And then on the synthetic fuel side, our core strategy or our core kind of understanding is that it's really just a thermodynamic battle. As in, to capture CO2 from the air, if you look at the thermodynamic limit, you ultimately have to go to very, very, very cheap energy input, because pulling 400 ppm from the air is non-trivial, requires a lot of fan power or whatever solvent you may use. And then actually producing hydrogen from water, again, is just rooted in thermodynamics. It's very energy intensive. I think it's about 33 kilowatt hours per kilo of hydrogen, meaning you're incentivized, you're driven, you're motivated to go towards the lowest price energy that you can get to. And as this is all happening, solar has now reached the cliff where it's all this quote unquote too cheap to meter. And basically what Rivan does is we vertically integrate every single section of synthetic fuel production, all the way from owning our own solar to building and designing, manufacturing our own DAC system. Same with our alkaline electrolysis to produce hydrogen. Same with our reactor to synthesize those two gases together into various on-chain hydrocarbons, all the way through to our distribution. So we have to own all of that to really get the pricing we need to drive down the cost of capturing carbon and producing hydrogen. And then also, not only do we kind of horizontally integrate all of those that I just mentioned, we also vertically integrate from design, manufacture, build, and deployment. So we look at it far more as a kind of vertically integrated manufacturing strategy, utilizing very, very cheap input energy, e.g. solar, to induce a learning rate into capturing more carbon, driving down the price of capturing carbon, and basically showing that there's a way to get towards the $100 and then $10 a ton mark, really.
Oh, curious, a bit of a technical question kind of popped up in my mind. How much CO2 do you need to produce, say, a kilogram or like a ton of synthetic natural gas?
Good question. I think I don't have the figures to hand right now, but our system, to give you an idea.
Roughly, maybe any idea?
A 1 megawatt system for Rivan captures on the order of maybe 250 to 300 kilograms of CO2 a day.
Mm-hmm.
So it's not huge, but it's also, these are modular systems. So then we sell that in the hundreds and the thousands. But yeah, roughly like that. What I would say though is the methanation reactant, so the Sabatier reactor that we've built, is 99.9% efficient. So any CO2 that we deliver to the reactor, it reacts away. If you design it effectively, it reacts away into CH4. If you mix it with H2 and a stoichiometric ratio, the hard bit is obviously getting that molecule from the air. That's the real challenge for us.
Right. Can you share anything about the type of technology you use? Because I know that, so first off, I think we didn't mention, you use direct air capture, correct?
Yes, indeed. Yeah.
Yes. So I know that there's kind of like these slight technical differences. Everybody has their own thing. Can you share a little bit of what and how you do that?
Sure. So we currently use a calcium oxide looping mechanism. So it's fairly energy intensive or thermodynamically inefficient, which basically the limestone cycle that we all kind of learned at school, whereby you have calcium hydroxide that acts as your carbonation solvent. So basically we blow air over that solvent to capture a certain degree of CO2 from the air. It then turns into carbonate once we've captured that CO2, and we then have to heat it. So the calcination process, heating it up to anywhere from, depends how you run the system, but anywhere from say 600 to 900 degrees. It then basically splits into CO2 that we pull away that's very, very pure, that we then use, we dry, maybe compress it into the reactor, and then you're left with this spent oxide that we then rehydrate as the third step, and then it goes back into hydroxide, and we perform this loop. I think what's interesting about it is that there are no consumables in that process. What if we start with, say, a ton of limestone or calcium hydroxide? There's loss of sorbent and there's sintering over time, but really we keep that for years and years and years and years. So it's very cheap as a sorbent to get going. The caveat to that is that you have to apply a vast amount of energy to it in the form of heating to really decompose that carbonate into oxide and CO2, which is our kind of core area that we focus a lot of resource on.
Okay, thank you. Harvey, I also know that Rivan recently raised 10 million pounds. If you could share what this funding is aimed for, what you're hoping it'll go toward.
Sure. Well, our manufacturing is expensive. So we raised the capital as seed capital as the first external money into the company. To basically do a couple of things. One is to try and scale our pilot. So we currently have what we believe is the largest synthetic fuel plant in the UK operating in Wiltshire currently. So there's a lot of just scaling to do on that and learning and kind of iteration of that design. And number two is just a load of R&D that we have. So for example, if you think about all of those systems, solar, DAC, electrolyzer, reactor, on each of those, there's varying degrees of surface area where we can reduce costs, increase simplicity, increase performance, various kind of design iterations and implications that we can work across. So there's a huge amount of R&D. And then lastly is putting in place our manufacturing. So if we're going from our pilot into tens, hundreds of thousands of these systems, because we vertically integrate everything, all manufacturing is under the same roof. There's just a lot of work to do there. We go right to the bottom in terms of we bend the seal for, it might be our carbonation bed, we orbital weld our reactor, we hydro test it, we kind of cut our own electrodes, we stamp our own gaskets. We pretty much do everything, and because it was the only way we thought that we could control the price of the levelized cost of the synthetic fuel at the end, and like in terms of like really control it. And also just to drive down costs as fast as we possibly can and not rely on external subcontractors and things like that.
Are you guys looking to license your technology potentially in the future?
Maybe. I think right now all we're focused on is driving down the cost curve of levelized cost of methane. That's really our critical focus. E.g., we know the inputs that drive that, and every day we try and influence them in some degree. At some point, if the main influencing factor is external parties or partners that may help with that, then yeah, definitely. But right now, we're focused on owning every part of that section to drive that cost down.
Okay, understood. Harvey, moving on to bigger picture matters, I wanted to gauge your perspective with regard to the political and regulatory landscape for carbon removal in the UK. How much support is there currently from your perspective for the sector on that front?
Rivan is a little abstracted away from policy and regulation currently, in terms of we've just been so focused on designing our system and less on maybe the political support that we may or may not have. I think, and also for the fact that we're partially a carbon capturing company, we're partially a hydrogen generation company, we're partially a fuel synthesis company. So there's a number of kind of tenets to that, and like where we would sit is maybe a little ambiguous. And then also the fact that this pathway that we're pioneering in terms of how to produce synthetic fuels in the way we're doing it, especially in the UK, is just completely novel and doesn't really fit into any regulatory framework. So I think there is clear support for things like synthetic fuels in the UK. We have the RTFO order, which is a renewable transport fuel obligation. It's a really great kind of political driver or regulatory driver to decarbonize heavy transport. I think it's great. We also have the SAP mandate for sustainable aviation fuel. Rivan isn't currently supported by these mechanisms, and we're currently kind of running our own race. But I do think there is general, there's generally a good feeling, I would say, in terms of the support, as long as you can make it financially viable. And I think that's been the kind of core tenet to everything we've done at Rivan right from the get-go, is how can we make these systems really, really cheap and really, really robust. So yeah, whilst we're not currently supported, I have conversations all the time with kind of these bodies, and we're just trying to figure out where we stand more than anything right now. And also what we tried to do is, instead of looking for support right at the start, we tried to be what seems quite rare in getting hardware out on the ground and showing people that it works really effectively, and trying to do that with our own internal capital and things like that prior to any kind of request for support. And that currently is working okay. I think it's very rare to see, from what we've seen at least, that a company can manufacture everything, get it out on the ground, do it very quickly, and hopefully that has a kind of a pull for regulation to align with it.
I definitely agree that this type of business model, where you can literally just, you capture the CO2 and then you can create something of value for it, so it basically pays for itself in the end, is the most successful that I've come across doing this podcast. So props to you for that, certainly. But as far as you said, as far as learning where you stand goes, you might just get your wish very soon. Just last month, the UK government launched an independent review into carbon removal technologies in line with supporting the UK's net zero goals, perhaps you've heard. And part of this process, as you might know, involves a call for evidence from industry stakeholders. So much like yourself, what do you make of this? And does Rivan perhaps intend on participating in this call for evidence?
I don't know that specific one, but yeah, we've been to the point of getting our pilot site out there. That's exactly why we've got it out there so quickly. And basically, Jahat as a point of evidence for this, they've done the same thing on the RTFO order. So yeah, I imagine it would be the exact same. There's a few course of evidence that we've got involved with recently. So yeah, hopefully we can kind of disambiguize what we're doing a little, because I think that's been the challenge for us, and just like filtering exactly how we do it and why it's different and why it's really important now, basically. I think the other thing as well with Rivan is that we don't intend on keeping this all closed off. So maybe contrary to my point earlier around partnering with companies or licensing the technology, hopefully what this will show is this is a pathway in terms of just the thermodynamics of capturing carbon and producing hydrogen, and actually a useful synthetic fuel at the end that is on par or close to fossil derivatives. I think if we can show that we can do that, I think many others will follow suit. Much like you saw in kind of the EV industry with Tesla in the early days, that then basically forced the industry into action. I think hopefully we can do something similar to that. So the greater impact for us basically is, I think, almost as a trailblazer for others to follow. I think that would be the biggest impact on the UK. And first of all, we need to show that it works.
I would agree, especially as far as the price point goes, because normally, like, everybody's pretty much agreed on the fact that DAC is super expensive, like way more expensive than like we're capable of deploying it at scale currently as it is. But your case certainly kind of shows a different way of looking at it and shows that it can be done.
Yeah, and I think also like the conversation around DAC being expensive is rooted in narrative and not necessarily the thermodynamics of it. There's a superlinear scaling coefficient with efficiency and cost. For example, if you've got a very, very efficient DAC system, for example, let's take an arbitrary efficiency. Let's say 70%, which is insane, but 70%, and it might cost, I don't know, $500,000. And when you drop that efficiency to 60 and to 50, it doesn't drop to 400,000, 300,000. It will drop to 100,000 and 50,000. It drops dramatically in price, super linearly. And when you're talking about ultra cheap energy, like solar and some wind to an extent, to benefit from that, you counterintuitively have to use more of it. So actually, really, the Goldilocks zone is not this high efficiency, high capex system, e.g. what the current state of the art is with DAC and why the narrative is just so expensive. It's actually, in our mind, utilizing vast amounts of very cheap energy with very robust, simple, and semi-inefficient systems. Because when you really extrapolate all of those numbers out, you start to get, basically it starts to become the only way that you can get close to what's required from a pound per ton or dollar per ton mark.
How about MRV? Like, how do you approach that? Do you have someone from the outside come in and, verify basically that like what you say you're removing is what you're removing?
Yeah, exactly that. So we currently, and that's one of the reasons again why we've got the pilot plant out the door. For our customer offtakes, we have to have various kind of certifications in place, and we're going through that now. It's not just on the carbon itself, but also there's quite a lot in terms of the gas itself is called GSMR spec. So we have to hit certain specification for the fuel before it can actually be utilized. We have to hit other specifications if we're to sell in other countries. So yeah, there's a number of certifications that we're going through right now.
Okay, understood. So with all of this in mind, how do you see the industry developing in the coming years, both SNG and synthetic fuels and carbon removal?
I think Rivan's personally looking at the industry a slightly different way. Like I was saying before, just our core focus on manufacturing and vertical integration. So hopefully we can show that is the right path. I think it would be great to see others follow this, whether or not it's synthetic fuels or hydrogen or carbon or batteries or whatever that may be. I think that just vertically integrating and manufacturing first is probably the way to go, and hopefully we'll see more of that. And I think the industry will follow, especially if you create a new standard within the industry. Often it follows just because of kind of market design. So hopefully we see that. I think also, like I said before, if we can validate that this is a pathway or synthetic fuels in this way is a pathway, I think it will drive everything forward. There'll be far more bodies involved, far more investment will flow in. And that's what I imagine will happen over the next few years, because people will start to understand just how cheap solar has become and how to utilize that effectively. And then also, I think there is a growing consensus that batteries are incredible, and the electrification of everything is incentivized and is happening, is brilliant pretty much just in every scenario. But there are these industries that you fundamentally can't electrify. And I think people will get a greater grip of how we're going to really solve for them long term. I think there's discussions around biogas, anaerobic digestion and things like that, which are okay, but they don't really hit the price point. So I think hopefully we'll see a lot more innovation with that. Yeah, as we move forward, basically.
Just a quick jump back to something you said earlier in the podcast. You mentioned carbon credits and like being a bit skeptical of them and like the carbon markets in general. Would you care to expand on that a little bit?
Sure. Yeah, I think it's maybe less my skepticism on the credits themselves. It's more if a product. It's more if you start on one side, which is what is the price that we need to hit from a capture like dollar per ton mark for huge impact. And when I say huge impact, there's some great graphs on this in terms of some of the largest emitters in the world. Let's say they make between $1 and $100 per ton of CO2 emissions. Someone like BP or Shell or large scale emitters like that, their profit margin isn't huge per ton of emission, unlike that of Apple and Microsoft that are leading the way with their programs and carbon offtake agreement. But then you look at that and go, okay, well, if you take 1%, say, which is quite a lot, 1% of their total profit, you can actually, they can only afford about $1 a ton of carbon that they emit. So something fundamentally has changed. Like carbon credit the carbon credits as a system, as a structure, won't drive us to that. And therefore, really, why I mentioned about kind of the skepticism around that is the only way to get even close to that is to induce such a ridiculous learning rate, such a ridiculous price drop. And the only real way to do that is to create a market or operate within a market where the product that you're selling is greater than the sum of its parts, e.g. greater than the CO2 that you've captured. For example, if CO2 is very, very, very valuable to the world right now, it wouldn't be in the sky. People would have found economic ways to mine it. And that's essentially what we're trying to do. So I think really my skepticism in the credit-based system isn't necessarily that it's inherently bad. It's just I don't think it's the best vehicle to drive down the costs as fast as you possibly can. And actually free market dynamics that have happened over and over again in history for product innovation is pretty much the only way. So that's what we're trying to drive against. And that's why ultimately, although the aim is actually very carbon, we're using a mechanism of synthetic fuels to do so.
It's a really different and valuable perspective, and I thank you very much for that, because I talk to people mostly who are on this like kind of one track. They have this one track mind that carbon markets are like the only way that we can scale carbon removal, and this is literally the only business model for any type of climate action. And it's nice to both hear a different opinion, but also see that in practice there are indeed other pathways.
Yeah, and ultimately, I think we're all in the same game. Like whatever we can do to drive down the cost of capturing carbon, we should do. And currently our core hypothesis is that this is the best way for us to reduce the learning rate to get down to the prices that are sustainable and actually have huge implications on the world. Let's see if we're correct. Hopefully we are to some extent for just the greater good in general. There's definitely other mechanisms as well, right? And for example, if you scale Rivan in the limit, we will produce terawatt hours and just an obscene amount of synthetic fuels. And that will enable a load of carbon that previously would have been emitted from, say, gas being burned that came from a fossil source or derivatives of SAF or aviation fuel and things like that. So it'll allow a lot of that to be kept locked in the ground. But equally, there's a vast amount of carbon in the air that we're going to need to capture anyway that Rivan isn't going to necessarily be able to take care of because we have a cyclic operation, right? In terms of the carbon that we capture then turns into fuels and back around. So I think we've got to work together on it. It's just, our current leading hypothesis is that the only thing that matters is inducing a learning rate. It's the whole point that Rivan is modular, the whole reason we manufacture first. So all of this is to aggressively drive down the price.
I'm glad you mentioned Rivan and terawatts, because we are coming up to my final question for you, which is what Rivan has lined up for the next weeks and months. Are there any exciting new developments that you can already hint at?
Yeah, I think so. We have, like I mentioned, we have our pilot site live currently in Wiltshire on a decommissioned Air Force base. And yeah, to the best of our knowledge, it's the largest synthetic fuel plant in the UK. We're trying to 10x that by the end of the year. And there's just a vast amount of architectural decisions and engineering decisions and production decisions to have. So that's kind of our core landmark right now that the team is focused on. And then from there, we're rapidly aiming to go into manufacturing and kind of commercial deployments that will be upward of 10 to 100 megawatts. That's pretty much all that I'm working on right now. So yeah, that would be the most exciting kind of landmark for us, would be the end of the year once we've really scaled up our operation. I think we have an amazingly committed team of engineers to do so. So yeah, hopefully we can pull it off.
Yeah, it definitely sounds like it sounds challenging. I mean, 10x by the end of the year sounds like wow. Sounds like a lot. But yeah, it's very exciting, and I really can't wait to be updated on your progress. Harvey, thank you so much for being here today. It was a real pleasure to speak to you, and props to you and to Rivan and everyone on the team and for the things you're doing.
Thank you very much, Bella.
If you enjoyed this episode of the Carbonsations podcast and would like to hear more conversations like this, please be sure to subscribe. We really appreciate the support.